A very good day, dear students. So I'm Shomodi, your faculty for robotics. And since we have moved from our previous session into the software part, so let us continue that. Okay. Let us know more about some syntaxes in our coding language, in our Arduino coding language. Let us move further. So here we are with the slides. And let us begin. Let us continue the session, not begin. So see, this is what we have seen previously, right? In our previous class, we've seen the difference between the void setup and the void loop. Let me repeat it once again for people who might not remember it. Void setup. See, the name itself is setup. So what we are doing is we are setting it up, right? For our future further programs, we are setting it up. So whichever things need to be defined there. That means by that, what do I mean? I mean that if you want to make your, for example, in a blink code, okay, in your blink code, what you want to do is you want to make your 13th pin, that is the inbuilt led inbuilt pin, your out. So you need to define it in the word set, because that's a one time job. Okay, it's not something that you need to do again and again repeatedly. That's a one time job. All right, understood. So those things which need to be defined once, and that's it. That's all for the code. That those things will be given in the void setup statements. All right. Okay. What will be there in the void loop? The name itself suggests loop. So things that need to be run again and again, one after the other, that will be present in the void loop. Okay. All right. So these are two blocks that we can say in our programming, in our coding. Fine. Now, functions. What do you mean of functions? Let me show you properly. The functions in Arduino combine many pieces of lines of code into one. Okay. The functions usually return a value after finishing execution, but here the function does not return any value due to the presence of void. All right, this is the case for Arduino. The setup and loop function have void keyword present in front of their function name, as you can see. Okay, since void keyword is present, that's why you see there will be no return. Okay, the multiple lines of code that a function encapsulates are written inside curly brackets. We all know that. Like, if people don't know that, even you can note it down. Okay. So curly brackets, they are important for points that we write, points of code that we write. Every closing curly bracket must match the opening curly bracket in the code. So as I said previously, also in the previous session, that with every bracket opening, you must close it and then write the code inside it. So it will be easier for you to track that you've provided the closing bracket for every and the other opening bracket or not, or else somewhere or the other you might make one or two mistakes. Then comes spaces. So spaces, Arduino ignores the white spaces and tabs before the coding start. Okay, before the coding statement is given, Arduino ignore all the white spaces. Okay, the coding statements in the code are intent for the easy reading. Okay, that is empty spacing at the starting. So basically, the spaces that we provide, that you see when we will be coding in the sessions, before starting of the lines, there are 2 to 3 spaces provided. Okay, it depends on the structure, but like it is easy readable. Okay, easily readable for people who doesn't actually know. Okay, it's easier that way to read the code. Okay, so in the function definition, loop and conditional statements, one intent equal to 2 spaces. Remember that. This need to be remembered. The compiler of Arduino also ignores the spaces in the parentheses, commas, blank line, etc. Okay, these are about spaces. Now comes the tool tabs. Okay, the verify icon present on the tool tab only compiles the code. Okay, that is what we need during every code, the compilation of code. So we'll be using the verify icon. Okay. So it's basically the checking part. We check the code, we check the accuracy of the code by that verify button. To compile, run, and upload the code on the board, we need to click on the upload button. So while clicking on the upload button, by clicking there, we basically we combine all three instructions over here: compile, run, and upload. Then comes the parenthesis. We all have discussed this in the previous session also. It denotes the function like void setup and void loop. It denotes. Okay. The parameters inputs to the function are enclosed within the parentheses. It is also used to change the order of operations in mathematical operations. Okay. Then the very like one of the most important things I must say, semicolon. Now, why I'm saying one of the most important thing? Because every and the other person coding in Arduino, or not only in Arduino, but in other programming languages also, somewhere or the other, someday or the other, they will miss one or two semicolons. Okay, students, so don't worry about it. So semicolons are basically it shows the end of the line. Okay, it is a statement terminator. As you see, it shows the end. I said it is the basically statement terminator in the C as well as C++. Okay, a statement. What is a statement? A statement is a command that is given to the Arduino, which instructs it to take some kind of action. That means, for example, if I am asking you students, please note it down. So that means I am giving you a command, and what is your action? Noting it down, right? Listen to my command. So that is it. Hence, the terminator is essential to signify the end of a statement. That's what I said. Okay, that's what being said from the start, from the beginning. That we need to terminate a sentence, right? An instruction, if I give, we need to terminate it. So who will terminate it? In this case, the semicolon. Okay. We can write one or more statements in a single line, but with semicolon indicating the end of each statement. All right. The compiler will indicate an error if a semicolon is absent in any of the statements. All right. It is recommended to write each statement with semicolon in a different line, which makes the code easier to read. You see, Arduino is a very primitive language. Okay. So all the beginners and everybody will be like using it. So it's very important that we make our code, we make the code readable. Okay. So all the lines with semicolon, ending with semicolon, they must be written in separate lines. That's what it means here. We are not required to place a semicolon after the curly braces of the setup and loop function, of course. Arduino processes each statement sequentially. It executes one statement at a time before moving to the next step. So one by one execution is done in Arduino. Keep that in mind. See, this is the process basically. The Arduino coding process in the form of the flowchart. You see, first we start, then the setup, then the loop. That means void setup and void loop. So in void setup, the compiler reads what is the setup that we want, which pin to output, which pin is the input, or anything like that. And then comes the loop, which runs again. Okay, easier to understand. Now comes Arduino serial begin. Okay, or serial.begin, whatever we say. The serial communication is a simple scheme that uses the UART. Okay, it is universal asynchronous receiver or transmitter, UART. Okay, so 5 volt for logic 1, that is high, and 0 volt for logic 0, that is low. When it is digital pin, so 5 volt and 0 volt is represented by high or low. Now, every message sent on the UART is in form of 8 bits. That is 1 byte basically, where 1 byte equal to 8 bits. Okay. See, this is where the TXRX pin is located. It might be blurry, a bit blurry over here, but here you can see it in zoomed in. The messages sent to the computer from Arduino are sent from pin 1 of the Arduino board called the TX, that is transmitter. The messages being sent to the Arduino from the computer are received on pin 0. That is the see pin 0 over here, 0. That is the receiver or RX. Okay. If you have the Arduino with it, you can see. So the pins are connected to the serial TX and RX chips, which acts as a serial to USB translator. It will act as a medium for the computer to talk to the microcontroller. Okay, that is why this TX RX pins are very important. Okay. So this was it for this session. Okay. So let's keep it a bit short. I hope you've understood all the nitty-gritties of coding and the syntaxes over here, right? So from the next session, we'll again get into the coding. I will teach you how to code. Okay. I hope you have enjoyed the session. A short session it was. Thank you very much for being so patient, dear students. All the best. Let's see what happens.